here we will deal with the topic analog circuits. The subject name is analog circuits, as I have revealed to you. So it is analog circuits, and in the analog circuits we will be dealing with unit 5. So unit 5 is all about op-amp and its applications. Yesterday I have told you why do we call it op-amp? Why do we call this chip as op-amp? You have any idea? Now can you answer this question? Why do we call it op-amp? So op-amp is one of the versatile analog building block. So it is a chip, and it is an analog chip. Chip is also called as an integrated circuit. So we also call it as an integrated circuit. Can you see the whiteboard? Students, can you see the whiteboard?
Yes, sir.
So the chip is also called as an integrated circuit or an IC. And I told you why do we call this analog chip? Because by altering the external components, we can change the functions. So that is why we call it as analog IC, because we can make it function as a rectifier. That means we can use it as a device for conversion of alternating current into pulsating direct current. So here we make use of a rectifier which is called as a precision rectifier. So we build a circuit using this called precision rectifier. We can make use of this circuit as an adder. We can use this as a subtractor. We can also use this as a differentiator for differentiation. We will discuss all these applications. Why do we call it amplifier? Because amplifier is a device that converts a small signal or a signal with a strength of the order of millivolts into a high strength signal, or maybe of the order of volts. So the factor of gain that is provided by the amplifier is called as the amplification factor, right? So the factor, if we represent that factor by A, then if input is Vi, output is V naught, then output will be, the output equation will be expressed as V naught is equal to A times Vi, where A is the factor by which the signal is amplified, right? Of op-amp, how op-amp looks like. So in the lab we have drawn this particular IC. So the IC configuration is something like this, with 8 pins. Here is a notch and here is a bubble. So we start from this side, number 1, 2, 3, 4. We go in the anti-clockwise sense. Then pin number 5, 6, 7, 8. Can you describe the pins one by one? Anybody among you? What is pin number 1 and 4? What is the role of pin number 1 and 4? 1 and 4 is used for, anybody can speak up? What is the role of pins 1 and 4? These are known as offset, null, adjustment pins. What is pin number 2 of the IC? Pin number 3? Yes, anybody can answer? हाँ बताइए. Anybody among you can answer this question? Yes. Can you hear me properly first of all? Yes, can you hear me properly?
Yes, sir.
So answer इसका बताइए क्या answer है इसका? What is the answer of the question? What is pin number 2 of IC 741? This is inverting input. Pin number 3 is non-inverting input. What does inverting input mean? Is non-inverting input. Pin number 4 is minus VEE. This is negative power supply. Pin number 5. Tell me. Pin number 1 and pin number 5 is offset null. I am removing it here. Pin number 1 and 5. Pin number 1 and 5. These are the offset null adjustment pins. Then pin number 6, like this. Pin number 6 is the output pin. Pin number 7 is positive VCC. So pin number 7 is VCC here. And pin number 4 is negative power supply minus VEE. Right? So this chip runs with a dual power supply. Right? Okay, we have reached here. This is the pin description of IC 741, and we can draw the equivalent circuit or equivalent block representation of IC 741. This is how IC 741 looks like. Am I audible to you right now? We can represent IC 741 in this manner with the pins 1, 2, 3, 4, 5, 6, 7. So this is pin number 2 here. Pin number 2 as inverting input, pin number 3. So symbolically it is represented by a minus sign here and a plus sign here. This is the output voltage terminal represented by pin number 6. Here we get the output voltage. Then we have the positive biasing applied at pin. Yeah. Yes.
Sir, screen visible नहीं है sir.
Screen दिखाई नहीं दे रहा है. ठीक है.
Sir, दिख रहा है sir.
दिख रहा है?
Yes.
So there may be trouble with your connection. ये देखिए क्या नाम है बेटा आपका? ये देखिए पिन नंबर. हाँ मनीष है, शायद नेट आपका स्लो है, आप देख लीजिए एक बार, रिफ्रेश करके देख लीजिए. पिन नंबर 4 जो है ये VEE है, नेगेटिव पावर सप्लाई, एंड बिटवीन पिन 1 and 5 we connect a potentiometer. I told you the role of this potentiometer yesterday in the lab. Can you tell me? Anybody can answer this question? A potentiometer connected between 1 and 5 worth 20 kilo ohms. What is the role of this potentiometer? It is used to eliminate output offset voltage. What is output offset voltage? Eliminate output offset voltage. So what can we do? What is the output offset voltage? At present I am giving you an idea. Output offset voltage is the we represent it by VOO as a subscript. This is called as output offset voltage. So output offset voltage is an undesirable voltage which is present at the output terminal of the op-amp. It is an undesirable voltage. So first of all, let us examine the terminals of an op-amp. What is the role of the input terminals of the op-amp? So we can have a look here. How many inputs are there in an op-amp? How many input pins are there? 1 or 2? How many inputs are there? Yes, students, answer the question. How many inputs are there? How many inputs are there? Pin number 2 and pin number 3. कितने input हैं?
2.
2 inputs are there. So because of this reason, we can use this chip to perform mathematical operations. What are the mathematical operations that I have told you? Various mathematical operations that can be carried out with this chip are addition, subtraction, differentiation, integration. Also, this can be used as a log amplifier, log, anti-log. These are some add-on applications of IC741. So this chip, which is also called as op-amp, that is why it is called as op-amp, because it functions as an amplifier as well as it is capable of undertaking various mathematical operations. So if you have a look out on, if you just look at the diagram, this is the pin description. This is inverting terminal. This is the non-inverting terminal. What does inverting terminal imply? It implies that if we apply a sinusoidal signal at this terminal, at the output it will be amplified, but at the same time it will be phase shifted by pi radians. That means if we apply a signal at the input terminal of an op-amp, and which input terminal? Inverting input terminal. At the output, the signal will be inverted by 180 degrees. That means it will be phase shifted. It will undergo a phase shift of 180 degrees. At the same time, it will be amplified. On the contrary, or opposite to this, if we apply this signal to the non-inverting terminal, which is terminal number 3, then the output obtained in that case will be amplified, and it will not be having, it will not undergo any phase shifting. So this is the difference between inverting terminal and non-inverting terminal. Have you understood the difference between these two terminals, inverting and non-inverting? If we apply the voltage signal at inverting terminal, then the signal will be like this. It will be phase shifted by 180 degrees. At the same time, it will be amplified. On opposite to that, if the same signal is applied at the non-inverting terminal of the op-amp, then the signal will not undergo any phase shift. It will look like this. Okay? Is that clear to you? Can we go further with this? Okay. So we will just have an eye on various blocks of an op-amp. What are the various blocks? So I have shown you the pin diagram of op-amp, how the pin diagram looks like. Pin block